everybody, my name is Annika Jorgensen and I am the leader of the SWE Tutoring Initiative Committee, and this is the start of a new series that we're going to be doing of back to school videos. These videos are going to be playlists uploaded on YouTube, and they're going to go over concepts that you need to know before taking a certain class. This first playlist is going to be for calculus. This includes calculus for college students and calculus for like AP calculus in high school. So the first video in this playlist is going to be going over exponent properties. And as you know, exponents consist of a base, which is this big number here, and then an exponent, which is the small number up here. And all the exponent is telling you essentially is how many times you're going to multiply the base together. Or and a simpler way to kind of think about that is like how many times you're going to write the number down. So for example, for 5 squared, you're going to be writing down the 5 2 times, right? And then you're going to multiply it all together. And if you did 5 cubed, you would be writing it down 3 times, and then that would equal 125. So you raise the base to 1, you realize that you're just going to be writing down the base, right? And that's because the exponent tells you how many times you're going to write the number down, and so you're just rewriting it down 1 time. Okay, so now I'm going to show you 2 exponent rules that will help you simplify exponents, okay? And one of them is called the product of powers. And the product of powers is x to the m times x to the n is equal to x to the m plus n. And you can kind of like see where this is coming from by if you have x multiplied together m times, right? Which is just x to the m, right? And then you have x multiplied n times, right? Which is, then you can kind of see that if using the definition of an exponent, right? Which is how many times I write down the base on my paper, you can see that you're actually just writing down, if you're writing down the left side of the equation here, x to the m plus n, right? So doing this with numbers, you can see that if I have 5 squared times 5 cubed, then that's essentially writing 5 times 5 times 5 times 5 times 5 times 5, right? Which is then equal to actually m plus n, right? Which is just 1, 2, 3, which is just 1, 2, 3, 4, 5, 5 to the 5th, right? So another rule that's very similar to this is called the power of quotients. And the power of quotients reads x to the m divided by x to the n, which is equal to x to the m minus n. And it's so to kind of understand what's going on here, right? You have x to the m, right, which is just x written m number of times, and then in the denominator you have x written n number of times, right? And then because they're the same base, you can cancel out so many of these of the bases, right? And the amount that you're actually canceling out is x to the m minus n, right? So a better way to kind of like see what's happening is to do an example with numbers, okay? So if you have 5 to the 3rd divided by 5 squared, which is just 5 times 5 times 5 over 5 times 5, you see that you can cancel out, right? And the number you're canceling out is m minus n, which just reads 5, right? And just to reiterate, these two rules are just helping you to simplify exponents. And so from these rules, you can kind of start to think about, like, what would happen if I wrote x to the 0? Like, what does x to the 0 equal, right? And in fact, x to the 0 equals 1. And how we get that is using the power of products that we were using earlier. So if I have x to the n plus 1 written, okay, and using the power of products, we know that it's actually x to the n plus times x to the 1, right? And if we plug in 0 for n, okay, then you get, sorry, let's not write an equal sign. You get x to the 0 plus 1 is equal to x to the 0 times x to the 1, right? And then x to the 0 plus 1 is just x to the 1, which is equal to x to the 0 times x to the 1. And then if you divide x to the 1 over, right, you see that x to the 1 over x to the 1 is just 1. So you get 1 equals x to the 0, right? And then another thing, so you start to wonder, like, what happens if I do have a negative exponent, right? So what happens when I have x to the negative n? Like, what does that mean? And you can kind of see, like, where this answer comes from, of what x to the negative n equals to, kind of from the power of quotients rule. Because you notice that when you're doing the power of quotients rule, all of the exponents that were in the denominator ended up being negative, because, right, m minus n. So you can see that it would just end up being x to the n, right, in the denominator. And then this is kind of like, well, what about -1, right? And then if you just plug in -1 into this, right, you get x to the -1 is equal to 1 over x. So, but there is a special caveat to x to the negative n, and that is that x cannot be equal to 0. And this is because if you have x is equal to 0, then you get 1 divided by 0. And 1 divided by 0 is undefined. It does not exist. There is no answer, so no answer, quote unquote, so to speak, for that. And then from there, we can kind of start to think about what happens if we're multiplying, if we're raising an exponent to an exponent. And what I mean is, like, if you have x to the m to the n, okay? So you have x to the m, which is an exponent, and then you raise that whole thing to another exponent of n. And what does that equal? And x to the m to the n is equal to x to the m times n. And we kind of go about understanding this the same way as we did the product of powers. And that is, if you have x to the m times x to the m times x to the m, right? N times, right? And so because then this is through the definition of the exponent again, right? Then you see that you're just actually multiplying x to the m n times, right? So it's just x to the m to the n. I think the best way to understand this property is to do an example. So if you have 2 raised to 2 all raised to 3, right? And the first thing you do is, like, what does that mean, right? And that means that you are taking 2 raised to the 2 and you're multiplying that exponent 3 times, right? So that means that you have this number 3 times, right? So which just all that means is, right? So this is 3. So you can kind of see, based on how we did the product of powers, that it's just multiplying, right? So you get 2 to the 2 times 3, which is just 2 to the 6. And you want to be careful with this because you want to make sure that you're not confusing this with the first one that the first property that I keep referencing earlier, because in that one you end up, right, because if you have x to the m, x to the n is equal to x to the m plus n, you're adding that one, right? But you can kind of see why these properties are different, because this one, it's an exponent raised to an exponent, right? And this one, it's just two exponents multiplied by themselves. But you just want to make sure that you keep those straight, because in one simplification, you end with adding, and the other one you end up with multiplying. So for the next property is if you have two numbers multiplied together that you end up raising to an exponent. And how do you simplify those, right? And one way to do it is it's a distribution property where you end up distributing the n to both of the numbers. So you get x to the n times y to the n. And one way to kind of see how this works is with an example. So if you have 2 times 3 all raised to 4, what this means, right, using the definition of an exponent, is it's 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. And that's kind of confusing. So what if we rearrange this so we have all the 2's grouped together and then all the 3's grouped together, right? So then we got 2 times 2 times 2 times 2, right? Because we got 1, 2, 3, 4, right? And then we just do the same thing with the 3's. And then you have 2... 3 times 3 times 3 times 3, right? And you can see that you could just raise these to an exponent, right? Because an exponent is how many times the base number is multiplied by itself, right? So, which would just equal 2 to the 4 times 3 to the 4. Now you want to be careful with this property, because a common mistake people like to make is, like, let's say you have x plus y raised to the n. They want to, just how we did up here, they want to distribute it, right? And what that ends up, and then they're like, okay, well, if we distribute it, then it's obviously equal to x to the n, y to the n. But that's not the case, because if we did what we did in the numerical example up here, you can see that it ends up being x plus y times x plus y times x plus y dot dot dot, and then you multiply it n times, right? But the x plus y comes first before the exponent does, right? Because it's in parentheses, if you remember your order of operations. So you just want to be careful that you make sure that this isn't like you want to make sure you have your order of operations straight, right? Like exponents come before products do, but something in parentheses that's being raised to an exponent does not come before the exponent. So another property that kind of flows from this idea of taking two numbers multiplied together and raising it to an exponent is if you have two numbers divided raised to an exponent, right? And it's the same methodology that we did with the previous property, where you take x times x times x times x, right? Or dot dot dot, right? And it's all, and you're multiplying it n times, right? And you have y times y times y dot dot dot, right? N times again. And you sort of rearrange it, right? And then you realize that, okay, so if this number is all raised to the n, that means that it's x to the n, right? And then if you have this number raised to the n, then you realize it's y to the n, right? So it's the same kind of idea that where you just take the numbers and you rearrange them to make sure they all match, and then you raise it to the exponent. But you want to also be careful because this same rule does not apply up here, right? Like if you have, like for example, if you have x plus y in the numerator, and then you have w plus v in the denominator, right? And it's all raised to n. These are in parentheses, right? So you cannot make it, this does not equal x to the n plus y to the n over w to the n plus v to the n, right? Because you just have to make sure you get your order of operations straight. Like this thing is one quantity, right? And so is this. You can't have them, you can't separate them to exponentiate. So as our final property, we need to think about what happens when you raise a number to a fractional exponent, right? Like what happens if you have x to the m divided by n, right? And one way to kind of think of this is to, let's say you have x to the 1/2, right? We know that x to the 1/2 is actually just the square root of x, right? And what that means is that you have x on the inside, right? Square rooted, and it's actually, and you got this little 2 out here, right? And if we take that same methodology, you can kind of see that x to the 1/2 looks kind of like something that we could plug into m divided by n, right? If you want to look at this using fractions, we have x to the m divided by n, right? And then we can do x to the m times 1 over n, which is the same thing, right? And then you can clearly see that 1 over n is just the nth root, right? And then from there, we can do x is equal to x times 1 over n, and then exponentiate to m. And how we get this is from one of our done before, which is x to the m to the n is equal to x to the m times n, right? So, and then from this, if we want to go back to our square root interpretation, you can see that we get x, the nth root of x, exponentiated with m. So this is just multiple ways to look at how we can simplify exponents that are fractions.